my dear smart children, welcome to physics class. In today's class, let us explore some exciting concepts in kinematics. So before starting with, let us try to understand what is mechanics. So children, what is mechanics? It is the branch of physics which deals with the study of motion of objects in everyday life. I repeat, the branch of physics which deals with the motion of objects in everyday life is called as mechanics. And basically, these mechanics are classified into three categories. One is kinematics, the other is dynamics, and one more statics. So let us try to understand them in detail. Kinematics. Mechanics. Mechanics is the branch of physics which deals with study of motion of objects in everyday life. These mechanics are broadly classified into three types. One is kinematics, the other is dynamics, and statics. To understand with, what is kinematics? Kinematics is the branch of physics which deals with the study of motion of objects without taking into account the cause of motion. Without taking into account the cause of motion. Whereas dynamics is the branch of physics which deals with the study of motion of object while taking into account the cause of motion. You need to consider because of what forces the body is set into motion. Whereas statics means, the name itself indicates, it is the study of bodies at rest. So considerings is the branch of physics which deals with the study of motion of objects without considering the actual cause of motion. So not taken into account the cause of motion. And here you need to identify because of what cause the body is set into motion, taking into account the cause of motion. And statics means the study of bodies under at rest. With respect to a fixed point. So let us recall back. Mechanics is the branch of physics which deals with the study of motion of objects in everyday life. And this is broadly classified into three categories: kinematics, dynamics, and statics. What is kinematics? The branch of physics which deals with the study of motion of objects without taking into account the actual cause of motion. Whereas dynamics is the branch of physics which deals with the study of motion of objects while taking into account the cause of motion. Whereas statics deals with the study of motion bodies which are at rest condition with respect to some fixed point. Now let us try to understand what is a point object. So to understand with, what is meant by a point object? If you suppose that the size of the object is very small as compared to the distance travelled by the body. If the size of the object is very small as compared to the distance travelled by the body, we say that the body is considered to be a point object. For example, you know how bigger the size of the bus is? Suppose the same bus travels at distance of 100 kilometers. So clearly, if you compare the distance, 100 kilometers distance with respect to the size of the size of the bus is very small. And similarly, you know the size of the car. Okay. And if suppose that the car covers a distance of 50 kilometers ahead. So 50 kilometers distance is very long as compared to the size of the car. So in both the cases, in the first condition, as compared to 100 kilometers, the size of the bus is very small. Hence, the bus can be considered as point object. In the latter case, the distance traveled by the car was 50 kilometers. So the size of the car is very small as compared to 50 kilometers. So in the second case, the size of the car can be considered as a point object. Okay, so what is meant by point object? If the size of the object is very small as compared to the distance traveled by the object, in that condition, the size of the object is considered to be point object. Okay, children? So, size of the object should be very, very small as compared to the distance traveled by that object. Distance traveled by that object. In each case, we consider it as point object. Now, moving ahead, let us try to understand reference point. So, children, what is meant by reference point? So now let us try to understand what is meant by reference point. So children, what is meant by reference point? Reference point is nothing but a fixed point. What is that? A fixed point with respect to which the position of the object is to be considered. Fixed point with respect to which the position of object is considered. That means, you know, in mathematics, you study about origin. Okay. So here you go with the origin. Suppose this is origin, you consider it as a fixed point. And if you suppose that a body is set into motion, it may travel along x-axis, y-axis or anywhere or in a plane. So let us suppose that some body is traveling from one position to another position. Here it's initial position, here it is final position. Then initial position, we have to measure it from the origin. Final position, you have to measure it from the origin only. So, this point itself, where we are considering the position of the object, initial position and final position, we are marking it from here. So, this point is called as a reference point. So, what is reference point? It is a fixed point with respect to which the position of the object is being considered. Okay, children. And when do you say that, what makes the difference between, when you say that body is in the rest condition and what makes the difference between the body is in motion? So, rest and motion are somehow relative. First of all, let us try to understand when do you say that body is under rest. Whenever the position of a body does not change with respect to surroundings and time. I repeat, whenever the position of a body does not change with respect to the surroundings as well as time, then we say that the body is under rest condition. So you can observe that in your room, some benches, tables or board, whatever you have. So the position, their position is fixed with respect to the surroundings as well as with respect to time. So all the objects in and around your surroundings in the room right now they are in rest condition. And there are cases where the position of a body may change from time to time and with respect to surroundings. If you consider the motion of a vehicles, the revolution or rotation of the planets, and many examples are there. So these are changing their position with respect to some fixed position. So then those objects are said to be in motion. Okay, so what is rest? If the position of an object does not change with respect to surroundings and time, then it is termed as rest condition. Whereas when do you say it is a motion? Whenever the position of an object changes with respect to surroundings and time, we say that the body is set in motion. And remember that rest and motion are relative. Let us give an example, try to understand the same with respect to an example. Let us suppose that few people are traveling in a bus. Few people are traveling in a bus. If you observe that, let us suppose a bus is there. Okay, few people are traveling in a bus. Okay, and a person is observing the motion of the bus. Let us suppose that after some time interval, the bus has reached some destination. If the person outside the bus is observing these passengers, they appear as if in motion to this outside passenger. But if these passengers compare themselves with the co-passengers, there seems to be a rest condition. So if you focus on some passenger, let us suppose this passenger appears to be at rest condition with respect to the co-passengers, whereas the same person may appear to be under motion with respect to a person standing outside the bus. Okay, so we can say that the same person in two cases, in one case appears to be in rest condition, the latter case appears to be in motion. Hence, we can conclude that rest and motion are relative. Okay, children? Well, so next to that, let us try to understand the concept of distance and time. Okay, so before that, whenever you are considering the position of the object or the motion of the object, it generally based on three factors. One is reference point. The other is the distance with respect to distance covered by the body with respect to the surroundings. And finally, the time taken, the time that has been elapsed. Okay, so on three factors, the motion of the body is being calculated. Next to that, let us try to understand the concept of distance and displacement. Here we go with. Let us suppose that a person has covered a distance of let me change the color. Let us suppose that a person has covered a distance of 4 kilometers towards east in this direction. The person has covered 4 kilometers towards east. And then there he took a left turn and has covered a distance of 3 kilometers towards north. How much, children? 3 kilometers towards north. In this direction. And how much distance has he covered? 3 kilometers. Then what do you mean by distance? Distance means the actual length of the path. What is distance? The actual length of the path covered by a body is called as distance. So what is the actual length of the path covered by the body? From here to here, the body has covered 4 kilometers, and again from here to here, the body has covered a distance of 3 kilometers. So what is the actual path length covered by the body? 4 kilometers plus 3 kilometers. So together it is 4 kilometer plus 3 kilometer. So 7 kilometer is the total distance covered by the body. Whereas coming to the displacement, displacement is the shortest distance. So among all possible path lengths, one will be the shortest path length to cover from initial position to final position. And that might be like this. Okay, children. This is your initial position and this is your final position. Among all possible lengths, this is the shortest length. Joining from initial to final position. The shortest length from initial position to final position is called as your displacement. So, if it represents a right angle triangle, what would be the length of the displacement? This is 4 kilometers and this is 3 kilometers and this makes a right angle triangle. Hence, applying Pythagoras theorem, hypotenuse square equals to sum of the squares of the two other sides. So, what is this equals to? This is equals to root over 4 square plus 3 square. How much is 4 square plus 3 square, children? 16 plus 9. 16 plus 9 is 25. Under root 25 is 5 kilometers. Hence, the displacement will be 4 square plus 3 square. That is equals to root over 25. That is 5 kilometers. So, clearly, distance and displacement both are different. Okay. And there are possibilities where displacement and distance can be same. Let us try to understand the same by representing a number line. On this number line, if you suppose that this, we consider it as origin, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4, 5. Something like that. Let us suppose that a person has covered a distance of 3 kilometers towards east and again has covered some from here to here 5 kilometers again back. Then what is the total distance covered, children? In case 1, total distance covered is here 3 kilometers and again from here to here 3 and again from here to here 2. Totally 3 plus 5. How much is that? 8 kilometers. In the first examples, the person has traveled a distance of 8 kilometers. Okay. So, distance is 8 kilometers, whereas displacement in the first case is, displacement means, what do you mean by displacement, children? The length from initial to final position. So, where was his initial position? Here was the initial position. And where was his final position? Here would be a final position. What is the length from initial to final position? 0 to minus 2. It is minus 2 kilometers. In this case, displacement is minus 2 kilometers, whereas distance is 8 kilometers. Let us go with example 2. Example 2, if you consider, let us suppose that a person has started his journey from origin and has moved a distance of 4 kilometers and again reached back to the initial position. Okay, then in that case, case 2, we have, what is the value of distance covered, children? Distance equals to actual path length from here to here 4 kilometers and again from here to here. What is the actual path length? 4 kilometers plus 4 kilometers. How much is that again? This is 8 kilometers. 4 plus 4. It is the actual path length. So, the steps he will be placing, take a tape, measuring tape and just follow his footsteps. Then measure the total length covered. That will give you distance. If you consider displacement in the second case, what would be his displacement? initial position was here. Again, after traveling certain distance, again he reached back to the same position. So, in this case, the displacement is 0 because initial position as well as final position is at the same case. Okay. Here, the displacement is 0. Okay. Moving ahead, let us take one more example. Example number 3. Here we go with. Let us suppose that a person has traveled initially a distance of 2 kilometers and again from there 3 kilometers. Here 2 kilometers and then 3 kilometers. Then what is the distance traveled in the third case, children? Distance is equals to the total path length. Here 2 kilometers and here 3 kilometers. Totally how many kilometers? 2 plus 3 is 5 kilometers. But what about displacement? Displacement here initial position was 0 and final position was 5. So this initial to final, the total path length from initial to final position. Okay, that is called as a displacement. So what is that from initial to final? What would be its length? 5 kilometers. Here displacement is 5 kilometers. So, 3 different models I have explained you. In the first case, the distance was 8 kilometers whereas displacement is minus 2 kilometers. Second case, distance is 8 kilometers and displacement was 0. Third case, distance was 5 kilometers and displacement is also 5 kilometers. All the 3 you would have observed that the distance always takes a positive value. Whereas displacement can be negative, positive or 0. Displacement can be positive, negative or 0. All the cases, distance, in this case distance is greater than displacement. Here also distance is greater than displacement. But here distance is equals to displacement. So we can conclude that distance can either be greater than or equals to displacement. So let us try to write mathematically as so. So what is that, children? The distance is either greater than or equals to the displacement. Better way of saying is magnitude of distance is greater than or equals to magnitude of displacement. Or the displacement by distance is always greater than or equals to 1. Bring this distance here. Then this implies displacement upon distance can be greater than or equals to 1. Okay, children? So, the magnitude of displacement or distance can be greater than or observe this symbol, children. 1 greater part is here 1. Okay, so let me, instead of this, let me write it like this. Okay. So, the magnitude of the ratio of displacement to the distance is always lesser than or equals to 1. So, from this, we can conclude our topic, children. Okay. Then, we shall move to the some example problems we shall discuss and then we shall move to the next part. So, first question, a body moves over 1/4 of a circular arc in a circle of radius r. A body moves over a 1/4 of a circular arc in a circle of radius r. So, a circle is there. In that circle, the body is moving in a circular arc. The magnitude of the distance travelled and displacement will be. Here, you are asked to find the distance as well as displacement covered by the body. So, solution. So, what is given, children, here? Circle was given. In the circle, what this side is, a body moves over 1/4. See here, this indicates a full circle. Okay. Whereas this indicates a half circle, but as I have told you regarding 1/4 of a circle. 1/4 of a circle means it is divided into 4 parts. From here to here would be a 1/4 of the circular part. And what is the radius given? R is the radius of the circle. Let us represent R with the radius of the circle. The magnitude of distance traveled and also displacement. You are asked to find out the distance traveled as well as displacement. Children, if R is the radius of a circle, then the circumference of a circle is given by the circumference of a circle is given by the formula 2 pi r. The total length of the overall circular length is nothing but 2 pi r, where r is the radius. And as it covers only 1/4 of the circumference of the circle, hence 1/4 of the circumference of the circle, how much is that? 2 pi r by 4. Okay, so how much it would be? 2 goes by 2 times, hence your answer is pi r by 2. So this is nothing but the distance covered by the body. Therefore, the distance covered by a body during 1/4 of the circular arc. Therefore, the distance covered by the body will be pi r by 2. I hope you understood, children. So pi r by 2, you have this first option. You are also asked to find out the displacement covered by the body. Here we go with, in order to find the displacement covered by a body, so this was your initial position and this would be your final position. The line joining from initial position to final position itself defined as your displacement. This line indicates your displacement. To find the measure of a distance, let us also draw one more radius over here. Here it forms a right angle triangle. If this radius happens to the distance from center to that any point on the circumference is r, here also it would be r. Now observe the right angle triangle. One side is r, the other side is r. Then the hypotenuse would be root over side square plus side square. So how much is that, children? Root over 2r square. Hence, the value of displacement would be, so in this right angle triangle, the displacement is the line joining the initial position and final position. So this is nothing but hypotenuse of the right angle triangle. What is the value? Side square plus side square. This is r square plus r square can be written as 2r square. Root over 2 can be written as root 2. Whereas root over r square is nothing but r. So let us write r in front. Then what is the value of displacement, children? Displacement equals to r root 2. Hence your correct option is pi r by 2 and r root 2. Hence first one is the correct answer. Moving ahead with the next numerical. So the displacement of a point of a wheel initially in contact with the ground when the wheel rolls forward half a revolution will be. So what was given, children? Initially a wheel was given. Okay. So what happens means this wheel makes is set into motion. Okay. So this wheel, after moving, let me say like this wheel, after rotating, has covered some distance. Okay. So let me, then the wheel would have shifted its position to some new position. Let us suppose, let us try to understand. here. Initially, the wheel was here. After moving, the wheel would have reached the final position. Let us suppose that this would be the position, new position. What we have, the displacement of a point of the wheel initially in contact. Now let us observe carefully. This is the point of contact, the displacement point of the wheel initially in contact. This is initial point of contact with the ground. When the wheel rolls forward, what is happening? The wheel is moving forward like that. Whenever the wheel moves forward like this, when the wheel rolls forward, half a revolution. Half a revolution means the wheel like this, like this, like this. You see my thumb here? This thumb, after rotating, the thumb will go up. After half revolution, the wheel will go up. That means this point would have taken a new position, say some here. Forward half a revolution will be. Then what you're asked to find out? The displacement of that point of contact. Displacement means what I told children? The line joining the initial point to the final point itself is called as your displacement. The line joining the initial point to the final point itself is defined as displacement. So you are asked to find the displacement of this point. So you need to find out the length of this orange colored line. In order to find the length of this orange color, again you need to imagine the right angle triangle. So this can be your right angle triangle, isn't it children? In this right angle triangle, this will be your hypotenuse. The hypotenuse will be equals to squares of the hypotenuse square equals to sum of the squares of the other two sides. Clearly, if given that the radius of the wheel is r, if r is the radius of the wheel, let us suppose that here to here r, then here to here would also be r. So what is the diameter of the wheel? It is 2r. So what is the diameter of the wheel children? It is 2r. This length is given to be 2r. And it was also given that only half portion has been covered. So this portion after rolling has come the other side. That means this portion has come in contact with this ground. So this portion length is nothing but semicircular portion. What is the value of semicircular portion? The total length is 2 pi r. Half circle means 2 pi r by 2. So how much is that? Pi r. Hence clearly this length would be pi r. Sorry, the radius was given as capital R. So let me replace with the capital R only. So pi r. So clearly this length was pi r and this length was 2r. Now you need to find the length of this orange color line. What would be the length of this orange color line? It is nothing but root over pi r square plus 2r whole square. So let us try to find out. So hence the displacement is equals to root over this length. What is that children? Pi r whole square plus this length is 2r whole square. Let us try to simplify the same. Pi r whole square is pi square r square plus 2r whole square is 4r square. What is common in both children? R square. Hence r square into pi square plus 4 under root. Under root r square is r and left over is root over pi square plus 4. So which one is the correct answer children? Second one. R into root over pi square plus 4. Okay children. Hope you understand. So let me repeat the once again. This semicircular portion after rolling here has this position has come here so that this portion would have reached here. Then this the region semicircular region will be pi r because total it is 2 pi r, only semicircular portion is 2 pi r by 2, that is 2r. So as it touches the ground from here to here, the total length was taken as pi r and the diameter of the circle was taken as 2r. Hence the length from initial to final position is root over pi r whole square plus 2r whole square. After simplification, the displacement of the point of contact is considered to be r root over pi square plus 4. Okay children?